an introduction to artificial intelligence. We're just going to go through what it can do, how it's already in our lives. We're going to demo some of the AI, how we can integrate that into like web applications. Also show you some of Watson, which is the IBM AI that won a TV game show, and how we can use that. I just want to say I'm super excited. I looked through all the projects and they all look absolutely amazing. So hopefully you'll get something out of this, and maybe you can get some AI into your apps. So what's AI? So I put AI is hard to define because it's constantly evolving. What we called AI 50 years ago is not what we call it today. So we're going to broadly define AI as intelligent agents, humans or not, that can perceive their environments and take actions to optimize the chance of achieving some goal. So AI is around us. What I want you guys to do is just pop in the chat where you think AI might be around, where you've seen AI, where you might find AI, for example, in your lives, or you've used it at all. Just anything in the chat. I don't know. No stupid answers. YouTube video recommendations, excellent. Smartphone, yeah. Smart speakers, Google Photos, Google Home, Alexa, Spotify, yeah. Netflix, excellent. Yeah. So what? Yeah. Self-driving stuff. I like that. We'll talk a little bit about self-driving stuff. So in terms of AI, it is everywhere. You guys know that. We've got loads of things in the chat. We've got cars, we've got drones, we've got voice assistants, we've got cameras, toothbrushes. I'm not sure if maybe cameras came under smartphones, but we'll talk about that in a minute. So we'll talk more about driverless cars in a minute, but we've got smart speakers. We can program them to get gadgets on in our house just by using our voices. We've got smart toothbrushes. Oral-B has got something that uses AI. They say it uses AI to make sure you brush your teeth everywhere, so you're not missing bits at the back. So it will say, oh, you always miss the back bit of your teeth right here. You got to do that. So it links to your phone. Cameras, they'll pick up your face. Autofocus always looks for that thing, whatever's in the foreground. So it might be your face, it might be an object. And there's some really good AI models inside of those. Drones, so they can track you and not crash into things. So in terms of technologies, how many technologies that you have in your house that might use artificial intelligence? How many do you think you have? Just like a number, just stick a number in the chat. 1, 2, 10, 100, 5, 20. Wow. Wish I had 20 devices that had some AI in them. 10. Excellent. So we're dealing with people who kind of know. We know the smart technologies. We know that artificial intelligence is around us. Excellent. But what is that technology called in smart speakers? So what kind of AI? Has anyone done any kind of, just in the chat, if you think you know what this is called, the smart speakers, there's a name for this AI. Tech specs, Connor, excellent. Yes, so we've got smart speakers use natural language processing. This is one of the big things that has come out of artificial intelligence. We used to do, making a program that would swap words for words is it's quite easy in terms of splitting a string, making rules, but it's all rule based. And what if we have something like Paris Hilton is staying at the Paris Hilton, it's staying at the Hilton Hotel in Paris. That's a perfectly legitimate sentence. And there is, but if we're swapping Paris, we know that one is Paris the name, Hilton the hotel, and then Paris the place. So that it kind of stumbled and kind of stopped this language processing things. And we started learning about this, and we started using natural language processing. So we've got all of these wonderful things in our house, maybe. So what might be some of the problems of natural language processing? So I'm saying, when I say TV, what might be some of the problems? Anyone got any ideas? I know it's difficult to type, so I'll got malfunctioning. Yeah, can't infer the data. Accents, excellent. They can be hard to understand. Perfect. Yeah, loss of privacy. We'll get onto some of that. We'll be talking about ethics. It's really important. But yeah, so accents, regional sayings, slang, background noise. I've got lots of Australian friends, and we sometimes have no idea what we're talking about. They use different words. So they use, instead of a duvet, they'll use a doona. Instead of a pepper, they call it a capsicum. You know, these are things that we need to be thinking about when we're doing these, looking at these models. That's just one of them. There's 4 more. So just have a quick think about computer vision. What might that be? Just where that technology might be. Natural language processing. Where's that going to be? Smart algorithms. What do you reckon that is? And robotics and hardware. So what I'd like you guys to do is just maybe in the chat, say computer vision, and then an example of what computer vision might do, or what skill it might have. Natural language processing and what that might entail. So we've got our smart speakers, but is there anything else that we can use it for? Just give yourselves like 30 seconds in the chat. It'll seem like a long time, but I'll keep talking to fill the silence. Just start thinking about them. Anything for computer vision? What do we reckon? It's okay if we don't have any ideas, that's fine. Yep, hazmat men. Faces or objects, cameras, smart algorithm, works out math problems, not sure. Yeah, smart algorithms, they're gonna solve problems maybe with numbers. Yeah. We'll look how that works in a minute. Yeah, so well, in terms of computer vision, we've got image recognition, motion detection, character recognition from written. This might be used if you've used Snapchat, if you've used any kind of filter lens on any social network. They're using computer vision to map out where your eyes are, where your mouth is. So when you open your mouth, that tongue comes out when you look like a dog, all those types of things. That's using computer vision. Text scanners. There's text scanners where you take a picture of some text and it will take all the, it will use optical character recognition and it can change that into a different language. Amazing stuff. We've got our smart speakers. We've got text to speech. So it can change text to speech and speech to text. It can create natural language generators. There's things like if you fed NLP model the entire works of Shakespeare, and then you asked it to write something new based on something else, with a few tweaks and a few extra programming, you could get it to maybe spit out a new work of Shakespeare. And there's lots of, they use smart algorithms and stuff to make these wonderful pieces of art that simulate an artist that we can no longer, you know, obviously has died many years ago and we don't have any more art, but we love that style. And we can sort of simulate that with some artificial intelligence. We've got smart algorithms, matching services like Uber, Deliveroo, real-time health tracking, recommendation tools, which is all about our Netflix, our Spotify, all of the stuff that we talked about in the beginning that people were putting on the chat. that comes under those smart algorithms. And then we've got robotics and hardware, which is like this combination of delivery robots, robot assistants, production line robots, making themselves smarter. When they see something, maybe they're using something else, they're using computer vision to look at a box, and no, they're packaging it in a certain way, rotating boxes if they come down wrong, speeding up their own workflow, and actually having like these models built in, so we don't have to have such a rigid set of rules. So this box must fall in this exact way in front of this robot. Otherwise, when it goes to pick it up, it crushes it if it's in the wrong place. So there's lots of really, really interesting things here. So what we've done is, well, we've looked at your ideas. We went through all of them. Just again, I'm just blown away about how good your ideas are. Amazing. Have a quick think. Computer vision, natural language processing, smart algorithms, robotics and hardware. I want you to look for your name in this slide. The name of your app or project. Sorry, I keep saying app. What I mean is project. So I want you to have a look for the name of your project on here. Now, what I want to say is this is just us saying you could use this. You could go completely against us and you could use something else. This is us just thinking where it might be useful. You don't have to use artificial intelligence in your models. We'll talk about the ethics and everything later and the practicalities of it. So if it doesn't suit your project, it doesn't suit your project. If you're super excited about it and you want to get it in everywhere, great, let's go for it. If it makes your project better though. So here's what we thought. We've got these ones in computer vision. We've got natural language processing here. Smart algorithms starts with freewheelers and Tomodachi. And then robotics and hardware, we've got our robo-aids, medbots, AI load of rubbish. The rubbish one also could come under like computer vision as well, just because if you're looking at pieces of rubbish and you're trying to capture things, it can go in loads. Smart algorithms almost comes under everything, but we just tried to help you sort of give you starting points, really. Okay, so let's look at some case studies. I've got like 3, and then what I will do is I'll go into some demos, and then we'll come back and we'll talk about the ethics of everything right at the end. So self-driving cars are becoming, you know, this whole autopilot thing are becoming massive. Tesla, in my opinion, are leading the way in this. They're leading the way with electric cars and leading the way with this kind of technology. They work by using like an array of sensors and motors in and around the car, and they all speak to each other using complex models, AI models. One of the main ones they use is computer vision. So they use radar, ultrasonic sensors, and cameras. Now, this is something off their website. You can go to their website, read more about this. It's so interesting. We've got loads of cameras that are doing different things. We've got a forward camera, we've got a wide facing camera, we've got a narrow camera that looks ahead, and they're all doing slightly different things. So the narrow forward camera might be looking for things in the distance. The wide camera is looking at the peripheries. Periphery is basically the things around you. So when I say periphery, like they're looking at the bits at the side, looking over here, looking over here, looking at the stuff behind us. And you can see they've got full coverage in this picture. Now, in terms of how it uses computer vision, it might be looking for pedestrians. It might be looking for road markings. It might be looking for those stop lines on the road where you have to stop. It might be looking for stop signs. All of this is built into this computer vision. We've got facial recognition. Somebody mentioned this earlier. We've got the photos from iOS and iOS, and we've got Google Photos from Google, which can go on Android or you can get from Chrome. Now, this thing about facial recognition goes a little bit further. What it does is it will pick out faces in your photos. It can also do things like group all your photos, like all my photos that have my motorbike in it, all the photos that have my car in it, all the photos that have me and one particular friend. We can use these models and this facial recognition and computer vision to pick out things. We don't have to use it specifically on facial recognition. We could say, I want you to show me every picture where I've taken of food or of my dog or my cat. So there's some really, really interesting things that we can do with facial recognition. So this is Ed. I want to talk to you about Ed. His full name, Eduardo. He's 38, loves space because he works at the European Space Agency. He's working in Paris at the moment, and this is where he was born. I just want to take you, so I'm just going to come out of this PowerPoint for a second. If you can see this. He was born on this website. This is a made-up person. This person does not exist. If I refresh the page, this person also does not exist. This person does not exist. So we're using these smart algorithms to actually take bits of multiple pictures and knit them all together, or generate completely new, like ears and hair. This is a really good website. This person doesn't exist. We'll talk about why we can use it in how we can use that later on. But I just want you to think about how interesting and how like amazing this is. So it's really good. I've made up a character and I've got a photo to go with it. We've got learn how it works. We've got 3 videos from the guy who made this site. There's original, you can code your training model of your own, train your own thing to do something different if you wanted to. There's a simple version, there's a original version. There's loads of stuff, but I just thought I'd really show you this because this is like this smart algorithm taking information and generating something new. So what machines can do can be split into 4 main categories, and we've talked about those categories. But what are the operations that it can do? So machines are amazing at creating lists. So when you type something in Google, makes a list, and its algorithm prioritizes it for you. So the way that Google prioritizes its list is different to the way that other search engines like Bing and DuckDuckGo do theirs. Sorry, I can't think of any other search engines. And that's why some people have different preferences. It's why you can do one search on one engine and people are better at searching on Bing or better at searching on Google. You just get used to it and you know how you sort of inherently, you sort of work out how to search on a specific engine based on those algorithms. Classification, putting things into categories. This is a phone, this is something else, this is a dog, this is a cat. Association, which is our smart algorithms, finding links between things. So this is similar to this. And filtering, where we are removing unwanted data. So it's like, look through all the text in this book and find me mentions of my own name. So what it would do is it could go through and it would just go, right, find this, and it gives me like a paragraph. We tell it to say, give me the first page before this bit and the page afterwards. What we are going to look at is the idea of classification. I'm going to show you some classification models, and I'll explain how that works now. So classification is when things are put into categories or boxes. They're labeled. We're labeling things. So we're going to use colors as an example. And if you had to, because machines will only do what you tell them to do. If we had to classify things as black or white, what would you classify these colors as? I'm not asking you to put anything in the chat. but you're going to have some reasoning about how you would classify these. Okay, here we go. Black, white, white, black, white. Okay, maybe you can put it in the chat. This is exciting. Black, white, white, black, white. So that's interesting. Does anyone agree with that? Has anyone got anything different? I'd like to see if anyone's got anything different on the chat, actually. I think I would, black, black, white, white. Okay, so from those two, I'm assuming that what we're doing is we're looking at color density and how light something is rather than to how dark something is for the first one. So we've got black, and then we've got a lighter color, a lighter, and then it's a darker, so it's a dark purple, and then sort of a light pink. Now, then the other person has categorized it as the grays are black and the colors are white. This is the kind of thing that causes models problems. So we'll talk about this. Now, let's imagine I'm going to train a model. I'm going to classify images of dogs and cats. These are the images that I show my model, and I say, look, these are dogs. And you see something that looks like this, these are dogs. And this is a cat. Can anyone see any problems with this? What do you reckon my model might do to this? Only ginger cats. There's only one cat. Yeah, perfect. Not enough pictures of cats. That's exactly right. So when we look at this black and white cat that I've just put up on the screen, it doesn't actually look like this one. Like, they don't look alike at all. The ginger cat, I can't even see how many legs the ginger cat has. It's got dark eyes like this. So the eyes are sort of similar. It's got tiny little ears from what I can see there. The computer won't even know that there is. They'll just look. And it's different color. Whereas over here, we've got black noses, and every single one of these dogs has a black nose. So maybe that's how this model chooses to work out that it's a dog. It will go, right, so there'll be dark pixels surrounded by lighter pixels, and there'll be sort of this amount. They might be black and white. So this has got loads of black and white in it. So it's actually going to come up and it's going to say that it's a dog. Okay, and it's going to be pretty confident. Now, confident is a word that you need to know when we're talking about models. Machine learning models have a confidence level, and that's how they communicate to you how sure they are that they've got it right. So we'll look at one. This is from Teachable Machine that I'll get onto, and you can see the confidence levels. It will say I'm 69% sure. So for example, in rubbish sorting, 75% might be a good level of confidence. So if it's over 75% sure that this is a piece of plastic, take it out of the ocean and put it for recycling. But if it is medical based, and we're saying that this person, I'm 75% sure that this person isn't sick, is that enough? We might want to bring that confidence. I only want to pass people, and I only want the machine to make, if they are 100% sure or 98% sure that they are not sick, they can go to the back of the list, and we can prioritize people that they think maybe they're like, I'm 20% sure that they're not sick. Maybe a human doctor wants to see those people. It might change in terms of we've got rubbish sorting. It might change if you're doing something with that rubbish. So if you are like recycling it and you're putting it into a clothes recycler, and it turns out to be a bit of plastic and it's not a t-shirt, it's going to mess up your machine. It might cost you money. So you might want a higher level of confidence. Okay, so I've spoken for about 30 minutes. I'm going to show you something called Teachable Machine. So this is where we can train a computer to recognize images, sounds, and poses, as you can see in the GIF going on there. The reason that I want to show this to you is because I want everyone to be able to access models if they want to. And this is the easiest way of getting a image classification model or sounds into your project. It works with TensorFlow, works with ML5, P5, Coral, Node.js, Glitch, and I forget what this is called. But you've also got a Teachable Machine example PDF that I think Hannah has shared with you all. So I'm just going to come out of this, and I just want to show you Teachable Machine. So we're going to get started. So it's really simple. It's really easy. I'm going to do an image project. So I'm going to do something with emotions. I'm going to capture me, hopefully, being happy and me being sad. And then what we're going to do is we're going to use that and we're going to train this model to recognize when I am being happy or I am looking sad. And then we'll use that in an actual model in a second. So here we are. I'm using my other webcam, which is this one. I can hold to record. So this is me happy. Moving around a little bit so I can get different versions. Otherwise, what happens is it only thinks, you see, I've got my thumb here, and it won't. No, so I might do a few more. My thumb up higher, like this, moving in, so it stays happy. I might look a bit crazy, but I'm trying to be. This will be me sad. I'm not really sad. Don't get worried. I'm having a great time. Got to try and be sad now. So we've got that. I'm going to add a few more images because we've got to make sure that we've got about 193. It's not going to make a massive difference to us right now, but it's always good practice. So more sad. If I go over. Yeah, so I've got more sad, but that'd be fine. It's probably a little bit different. I'm going to train my model. Now, this is really cool. Teachable Machine will let you play around with these things. So you've got epochs. I'm just talking about it's every sample in the training data set has been fed through the model at least once. So if it's set for 50, for example, it goes through the model 50 times. So it learns it and goes, right, what's different? Something else, something else, something else. It's part of, we had a question about like how neural networks work. So if you imagine your brain cell, each one of your cells might do like a little job, and it will talk to another one and it will say, right, here's some information. You do another bit of calculation, you do another, and they talk to each other, and we get lots and lots of tiny pieces of information that we then form into like a thought or something. In a neural network, what they will do is we will have like tiny little mathematical functions. So we'll have lots and lots of little maybe functions like tell me this information, tell me this information, tell me this, tell me that, tell me this. And what happens is we used to, so 3 layers used to be really technical. Anything over 3 layers, they kind of call like deep learning now. So what happens is this layer of functions, you might have 4, talk to the next layer, talk to the next layer, and then there's maybe two functions at the top that make decisions based on all of that information. And they sort of feed into each other. And so we're getting information from those. So that's kind of, they're quite difficult to talk about neural networks and things, but that's sort of it in a nutshell. And there's lots and lots of great resources out that you can do. So I'm just going to train this model. Depending on the amount of images, I probably should have pressed train whilst I was talking, but depending on the amount of images, you know, it takes a certain amount of time. It won't take that long. This is taking way longer than I thought it was going to. But whilst we're training, I'm going to move back. So, because we don't need that right now, but so we've made a whole model. It's training perfect. Now, let me get back to the right slide. Otherwise, I spoil the magic. So we're going to look at P5 because we've now made a model, but we want to make something and we want to use that in a project. So we're going to use something called p5.js. Built on JavaScript and web technologies, HTML and CSS. Web technologies are accessible by any device that has a browser. People watching this could be watching it on their phones, any phone that has internet connection, Linux, Mac, PC, whatever. That's why I love web technology. I think it is absolutely amazing. And we're all using web technologies now. We're streaming, just amazing. I've got a couple of links there that I will leave up, and hopefully maybe Ed could stick them in the chat for me, saves me coming out of here. They're just bit.ly links. They are to some files, some actually examples of models built into this platform, and I've kind of I've played around, and I'll show you them now. So here's my model. So it reckons I'm happy. And if I do that, maybe I'm sad. I can't really tell because I'm looking over here. It was sad. Did I get some happy and sads in the chat? Maybe. Telling I'm happy. Sad. Cool. So we've got happy and sad working. So, I mean, obviously it needs to be more complicated if you are looking at the wrong camera. It needs to be more complicated if you are doing something for some kind of medical thing, but you guys can play around with that. I'm going to export my model. Now, there are loads of FAQs about how they treat your data. They do not store images. They just store the data that they have got from those images. So if you want to train lots of data sets, you need to download them. Okay, so let me just upload my model. And here you can click these and you can remove all the samples, download them, save them to Google Drive. Once this is uploaded, we get a little link. Now, if you wanted to start your own model, here is the P5 code that you could just copy and paste into P5 editor. So it's just uploading my model right here. And this is something that I built, and I built this to recognize me, a roller coaster, a coaster, and a bottle. And what we'll do is we'll just quickly go through and we will put, we will label it happy and sad. Now, our classes are called happy and sad. We're just going to do a little if statement. We've got the results and the label. So I'm just going to put in happy here. And if it's not happy, it's going to show me something else. So I'm just going to get rid of these quickly. So it's either happy or it's sad. We've only got two classes, so we don't need to do anything like that. So I'm just going to say sad. I'm going to change this to happy. So let me save this so you guys have got the same thing. I'm going to press play. And what I've done here is I've actually made the web page. So I've tried to make it look good. You won't see this kind of stuff if you start a new P5. All free, by the way, forgot to mention that. So what will happen is we've got an image, we've got our camera coming up here. I'm going to look at it. I'm going to give it the thumbs up or the happy and sad, and it should tell me whether, so it thinks I'm sad, and it thinks, might think I'm happy. Right. The reason it's not doing that is because I haven't updated the model. Okay, so it's actually thinking about an old model. It's trying to work out, it's never going to be happy because it's looking at different classes. So I can just do that. And basically, this is now my model. You could do this with your own models. You could put this straight into my P5 if you wanted and duplicate it. Not a problem. Or you know, thinks I'm happy, sad, happy, sad. Sorry, it's probably picking up my head position, but you can see that it's doing happy and sad. Now, why don't I? Because two reasons. Let's take this and put it into my new app. So I'm just showing you how to do that again. We go into the let image class. These gray bits, I've annotated the code, so I've like marked it out, put your URL in between the quotes. That's what you can do. You can play around with mine, see if it works. So what I'm going to do is I'm also going to take this, because I don't really want to, I'm not going to redo it. Get rid of this. I'm actually going to take this. I'm going to take this emoji because I want it to be an emoji. So we've got a happy emoji there. And I'm just going to grab another one, Emojipedia, my favorite emoji website. Looking for a crying. Because emojis are sort of a text thing, you can actually put them in lots and lots of apps. So you can put them in your Python as well. So if you want to really impress your teacher, you can get emojis in your Python apps, your console apps. So that's a freebie right there. So we got sad emoji. For some reason I've lost a happy emoji. Didn't save. And we will stick this in here. So sorry, I'm all confused then. I went from one thing to the other, back again. Here we go. You're gonna be amazed. So what I've done here is I've taken this video out because we don't need to see it. This could be a website that they come on, and we could have a different label, happy, sad. Can you see me? You probably only see me through this one. I probably look crazy. But this is really, so imagine the effects of this when maybe we could change the background color of a website based upon whether somebody was happy or sad. Maybe we can base the music that we play on the back of our websites, or we go to a website and it says, show me music to match my mood. Enable your camera. How cool would that be? We could set up all this wonderful stuff. Walking into a room and the lights turn on for specific people in the house. Yeah, really cool stuff. So we got that. Happy about that. Love that. That is, I'll show you one thing. The reason that I love this is when I share this, if I go to present mode, just comes up as a web page. It's all hosted for you. Everything's there. You don't need to do anything apart from this. So these websites, hasn't saved it properly as it's gone as a stupid bottle again. But these sites are hosted there and they can be embedded into anything. They can be embedded, you can host it on a Raspberry Pi. I heard that you guys all were given Raspberry Pis, is that right? Thumbs up in the chat to say yes or no. Yes, perfect. Thanks, Pauline. Thanks, James. So you guys all got Raspberry Pis, like a £10 camera. You've got computer vision on a Raspberry Pi. You can move that wherever you want. You can supply the camera. You can put that on as they walk in a room and it all lights up based upon their thing. So many cool things, all based around the teachable machine model and P5. Okay, so lots of people have got, oh yeah, so sorry, James has said it's got no internal camera. No, the cameras are like an add-on, but I think the cheap VGA ones is like, I think they're like £8 or something. I don't know how that kind of thing, but maybe it's something that you think about. Anyway, we've got a raised hand, but I'm really conscious about time. Could my little Lily, could you just put the question? Yeah, can we just stick the question in the Zoom chat and Ed will pick it up for you? Is that all right? Just got two. I promise it'll be really good. Watson's good because I know some of you are going to love this. Okay, so really quickly, IBM Watson. Why I love Watson. Huge list of built-in resources. Free access to commercial tools. That's right, free. My favorite word. Built-in data sets. So if you don't have this data, then you need to, it has some built in for you. It can be hosted on IBM Cloud, and you might want to use, why you want to use Teachable Machine over Watson is if you don't need a data set, or the IBM website is a minefield. I'll show you, and it's difficult to integrate. Yeah, I'm gonna power on because I am just, okay, so IBM resource list. These things are called resources, and you make services. So you can have cloud apps, you can have storage, you can put stuff on the network, you can make apps, there's developer tools, there's VMware, which is like virtual machines, you've got workspaces, you can create dialogues on something called Watson Assistant. Amazing. Now, an easy way of using some of these is something called Machine Learning for Kids. I've got some projects. Now, this is really cool. I've got something called just a text-based thing. And this is good because you can integrate it into Scratch, you can integrate it into MIT App Inventor and to Python. So what I've done here is I've put in categories: despairing, out of sorts, blue, glum, sad. I'm doing another health app. I've got happy, I've got all of this. Happy, sad, jolly, not sad. Sad, depressed, down. The reason I have to put in not sad is because if I put in I am not feeling sad today and I don't have this class here, it comes up as, it just picks up on the sad. Okay, so really, really quickly, I'm very sorry about the timing. I have got some machine learning for kids, Python. So when you go, this is code that it automatically generates. You just go to make, and when you click on these, it opens it up for you. And it opens up App Inventor with your machine model in it. And then you've got Python. I just want to show you really quickly. We've got two versions of the chat. I'm actually going to show you what the extended one is. The little one just is built in, but with a tiny little bit of Python knowledge, we can build something that is picking up those text. So all of this code, pretty much bar the time, is Watson. And I've just added a little if statement. If it comes up as sad, there we go, let's try it. So I can type in a massive sentence like, oh, I'm doing really, really well today. Thanks. Glad to hear it. So because I misspelled something, it thinks I'm happy with 50% confidence. All right, so if I do here, it's coming up high. I put in a little thing to make it look like a delay, to make it look like something. Not great. I'm sorry you're feeling sad with 50% confidence. So this is where your text stuff comes in, your natural language processing. Teachable Machine doesn't do that. Remember, you guys have got like tutoring 1 hour sessions to go through this in a little bit more detail. I just want to get on to the ethical side. It's really important. We've had some of the projects come up. Now, ethical implications. So questions about autopilot. Don't put answers in the chat. With it, you know, these are questions that you cannot answer. All right. What happens if a car has a crash? Who's at fault? Is it the driver or Tesla? Think about the decisions that the people, if you've ever been in a car, think about the decisions that people might have to make all the time. Do you know, what's the correct speed? Do you go a little bit under? Do you try and get to the speed limit all the time? Do you try all these questions? No answers. This is why the technology for this is there, but it's not necessarily, we haven't worked out these questions, and there's a lot of AI that we haven't worked out the questions of. Facial recognition. This is an actress who makes fun of Hillary Clinton. It's lighthearted, but you can see there are things called deep fakes, where somebody who has got the same hair, same makeup, everything like that, they just put your face on and can make really convincing like videos that aren't from celebrities and people that we trust. So we would trust a celebrity if they say something and it's not them, we can get misinformation, and that can have sort of catastrophic effects on how we view certain people and how we view certain things in our own worlds. Trust in machines. We place a huge amount of trust in our machines, which, you know, is unwise. Think about a GPS system that tells you to turn and you're like, there's not even a road there. If you just turned because you were like, GPS is right. This kind of trust might be placed in your projects. So you need to think about what happens if your project gets something wrong. How does that affect the user? So machines are not evil, they are not good. It's what we do with these models, facial computer vision. For example, GPS was invented to launch nuclear missiles, but it now gets Deliveroo to my door, so I can have my pizza, and it brings me all the stuff that I'm ordering from Amazon. Now all the shops are shut. Data. When you are creating applications, and especially AI models, you'll probably be collecting data on people, all right? Your projects are going to have sensitive data. If you're doing medical applications, they're going to have very sensitive data in them. And people might need to sign up and tell you about their lives. Make it clear what you're going to be using their data for, and be prepared for questions about that. So ethics in my project. So imagine you had a face detection app that changes the settings of lights in a room. Your dilemma could be, could the algorithm be used to track, for tracking people? Sorry, can we use for to track people? That is a spelling. I've obviously messed that up. But can it track you when you're in the front room? Does it know that I'm in this room right now? And can that be used against me? Translation app. Imagine if it's used in hospitals and it says that they're not allergic to this, or they are allergic, or they're taking this medication when it's actually another medication. What if it gets wrong? Is it affecting somebody's life? Is it affecting their care? Bike sharing app. Can it be used to track people if they get the wrong thing? Is somebody away from their house? If somebody wanted to rob a certain house, are you away from that house? And a robotic head that talks to you when you're lonely, imagine. How do you monitor the learning of that algorithm so that the head doesn't start being offensive and maybe making things worse? I'm feeling really sad today. Well, you should feel sad. You haven't got out of bed yet. How do you monitor that it doesn't get to that point? Quick ethics checklist for you guys. Where are you going to get your test data from? You could use that website that generates faces if you're going to use that. Are you going to be storing any data? If so, where are you going to keep it? make sure data is broad and inclusive. If you're making a visual recognition app, you need to have different ethnicities, different genders, different ages, different facial hairs, different glasses, everything that you can possibly think of. Try different variations of your model. It's really important. Mess around with those epochs, mess around with the learning rates if you can, and see what happens when you feed it different information with different settings. And make sure users are going to be happy with your app. Ask people you know if they'd use it. Really important. Some people have got really great ideas that are like so obvious, and it seems like such a great idea, but actually in practicality might be quite different. Like monitoring people like on a 24-hour basis, is that really ethical? Do people really want to be monitored 24 hours a day? Okay, sorry about that. How long have we got? We've got 3 minutes. I can go over as long as everyone's happy to go over, but I'd love to get some questions. We've created programs in Scratch using machine learning for kids, but there's no option to save it. So if you've done machine learning for kids with Scratch, that's amazing. Think about using the Python option or using the MIT App Inventor. They have save options. MIT App Inventor has the same block-based coding as Scratch. It's a little bit more complicated, but if you can almost take it block for block. Teachable machine with sound. Yeah, same thing. What it will ask you to do is you can record using your computer's microphone or any type of microphone. I suggest if you've got like a USB microphone like this, really good for getting those models, especially background noise. Remember, if you're going to be using your AI model for sound and you're going to be using it out and about, you need to record background noise that's out and about. You need the heavy traffic, you need a silent room, the TV on in the background, all these types of things you need to get in as your background data so it knows what to not look for. Yeah, teachable machine with sound, it's the same thing. You just use sound and it can come through. And there's a different model on P5 that lets you use sound. Yeah, excellent. Thanks, Ed, with the thing. That's all right. Libby, what have we got? Oh, can I give you the microphone? This is called a blue ball, snowball, a blue snowball. Yeah, I think you can get them. I think this was about 35 quid a couple of years ago. So there might be cheaper ones, but just this microphone is built to pick up like mouth noises. This is something called a condenser. It simulates a condenser mic, which is just a little bit more sensitive, and it's for like recording musical instruments really. So it picks up lots of nuances and lots of all of the right frequencies and everything. Really, really worth having if you're doing sound projects. Well, you're welcome, Lily. Welcome, James. Welcome. Yeah, you're all welcome. Yeah,
I just wanted to flag that I had launched the kind of evaluation little polls at the end, just so that they're there. But please do carry on answering questions. And if anyone else has some more, we'll stick around for kind of the next few minutes.
Yeah.
You know, it's been amazing, and I think everyone's enjoyed it. But yeah, as Fergus says, you've also got your one-to-one sessions, so do kind of take everything you've learned as well. Yeah, Ed's also popped that in the chat and the link to the Calendly where you can book in a session. So definitely use that. But let us know what you thought in the poll as well. Thank you.
Just gonna have a look. Was that Q&A? So you're trying to predict strings using, I've got a question that is predicting strings using our data set, but the total data we have is 12 pairs of strings. Are there any other for low data AIs? Ooh, you could, so you've got the data set is only 12 pairs of strings. Is that right? Provirus, SGS. I'm just trying to think. So, in terms of, yeah, so you've only got 12. Oh, are people going to be typing these in? Joe, I'm still talking to Provirus. And so I'm assuming that they type in a string, and you're going to like tell them if they type in 3 strings and they come up. No, they're DNA strings. Wow.
Fergus,
That's
something
crazy.
that also we can do is if the team champion for Provirus wants to email us the kind of question, we could also forward it on to you. And if you wanted to kind of take it away, and if you needed some extra resources or something to direct them,
Yeah, that's
to an
great.
option. So
Yeah, so what I'll do is that would be, yeah, that would be great. So Provirus, if you could just like send through, I'll reread your project again. And maybe what we'll do is if you haven't booked a Calendly, I'll talk with the tutor beforehand, and we can come up with some ideas about how we could sort of move forward with that idea. Yeah, I think that would be good.
Brilliant. I saw, Anna, that you've replied. That's great. Thank you very much. So I think unless anyone's got any other questions, if you want to pop them in the chat now, maybe we've got a couple more minutes. Otherwise, we will end the webinar. And just big thank you to everyone, and thank you to Fergus and Ed. It's been such a fun session. Glad you guys have enjoyed it.
I've enjoyed it, so I'm really looking forward to all of these. So exciting.